Okay, so today we're gonna go with some problems. And again, collab. Let's see, so I think we're gonna do problem 2.1, 2.2, 2.3, 2.4. Let's stick with these for now. So let's say 2.1, 2. Oh, can't use that. Let's call it 21 and 24. We can. Okay, that's great. So, like, let's pay attention that it's 2.1 through 2.4. Okay, so we do want to check our previous notebooks because it's basically just applying whatever we did previously. So this time we have... Okay, so basically very simple questions. Determine graphically the magnitude and direction of the resultant of the two forces shown using A, the parallelogram law, and B, the triangle rule. So we're not gonna do that, but we are simply gonna use whatever we have here, which is the like splitting the force into X and Y. And I think we actually did update that in our second example. So let's check that out. And this is the one. Yep. Let's see. Yeah, decompose looks better than XY. So let's do it. Let's call it self. I think we're good, but I think it's better to actually use this one since we already have that. So let's do it. We can use this one from example 2.2 and we're gonna use the get resultant from example 2.1. And we're kind of building our own library by now, but let's deal with it. We really need some more documentation here and doc strings so that it's clearer, but let's just use it for now. Okay. So okay. So we're basically going to go like, let's call the first force x1 and the second one x2. Yeah. So we're gonna go x1 is a force. Its magnitude is 900. Its direction is 30. Right? second one is 600 and the direction is 30 plus 45 is 75 plus 675 is x2, and we want to get the resultant, and we want the list of force. Oh, so the list of forces is basically x1 and x2, and the resultant is get resultant, and let's print this. Let's have it close by. This is good, and this is it. These are our results. So this seems good. Now it's basically just application in the next 4 examples, and I don't know, maybe even after that. So let's see. Right here, x1, let's call this one x1, so it will be 500 and the direction will be negative 35, right? Because it's clockwise from the x-axis. And the other one is 60 and the value is 800, and because both of them are in pounds, we don't care. And this is our resultant. And see, like, this is the direction, so the resultant will be somewhere here, and that actually makes a lot of sense, right? Yeah, so this is how it is. Like, yeah, like for example, if this one was here, the angle will be definitely between 35 and 60. Okay, so for the next one, we have 2.3. So both 2.3 and 2.4 use the same image. So basically for 2.3, P is 10 kilonewtons and Q is 15 kilonewtons. However, for 2.4, it's the same image, but the forces are this. Six gives. And all of these questions are actually like asking us to determine graphically, but we're not gonna do that, right? Because we're approaching the problem a little differently, but we are reaching the same results. So yeah, okay, so for this one, we're gonna take this same thing, and we know that P is 10. And for this side, like, everything is in conventions. So for us, let's assume it's the same as if it was like in a mirror. So let's assume that that this one is positive and this one is negative, and we know that this is our convention, so we're gonna stick with it to understand the resultant. So let's call the top one x1, and we know the value is 10, and the bottom one is x2, and we know the value is 15, and the top one, it's the direction is 25, the bottom one, the direction is minus 50, and we're gonna get the result, and the direction is minus 21, which will be somewhere here, and that makes sense. So for 2.4, we have the same angles, we just need to change the values. P now is 6, and this is 4, and our resultant will be closer to the x-axis, but it's actually the negative x-axis, but this is our assumption. But see, it's just like basically applying the numbers to whatever we already built before. Okay, so today we did problem questions 2.1 through 2.4, and it was a very straightforward application of what we have developed previously.